Alright, we're gonna try for something a little bit different. My YouTube career is floundering. I obviously don't post that much, so there's not a very particular reason why, but mostly to do with my brain and the fact that when I'm in here doing stuff, and I do like a lot of what I think you guys would find really interesting stuff, but it's all very sporadic. It's never a complete thought, if you will, so if I'm working on something small and cool, I don't feel like it deserves its own video kind of thing. There isn't like a start and an end. Sometimes you work on something and there is no end to that thing. You just start it and then, well, you run out of daylight, and then the next day you keep working on it. The issue with how my mind is, when I film things, I feel like they should have a start and an end, and not because I think they should, but because I don't want to go and then upload the footage, like actually edit and upload the footage. There's just something about, if I don't immediately do the thing, then I almost never do it. Like, I have hundreds of hours of just footage of stuff that I've done in here, and that could have been very, well, watchable videos, and I just don't do it. Because, like, a couple days passed since I recorded it, and I'm like, oh, well, that's now old stuff. So what I think I'm gonna do is I'm just gonna record stuff in here, and I'm just going to put them in videos, and basically the audience decides if they want to watch it or not, which is probably how it should be anyways. Most of them will not be complete thoughts, they'll just be what I'm doing in the shop or whatever I'm working on. So yeah, there was probably more I wanted to say, but because I'm in front of the camera now, I don't remember what I was talking about or lost my train of thought. So getting on to what we're going to do today is I'm working on midnight pivots, and the last time I did midnight pivots, I hadn't completely realigned the lathe, so I ended up realigning the lathe basically a month ago, but it's kind of been a constant thing. Everything from re-leveled it to the headstock, which was a pain, the actual spindle, like, head itself, and then did the whole thing. So since then, what happened was, the last time I made pivots, I got better at machining basically, and I re-leveled the lathe. So I decided that I have to redo the entire thing. I also made a couple of design changes to midnight. I seem to do that pretty frequently. I used to anyways. The design's pretty set in stone now. I made a couple design changes that mentally facilitated, or made me think I should redo the whole thing start to finish, because the issue with lathes and posting code from Fusion in the setup, no matter how good of a template system you have, if you have an older lathe that's basically not a Haas, there's very little support post-processor wise for older machines. It doesn't have to be a lathe, but a lathe is a really good example because Fusion's turning side is really not that fleshed out. If you're turning on a 2-axis lathe and using regular stick tools, it's very adequate. But if you start to get into, like, I'm using a lot of micro 100 tooling. Let me go grab one. So I have to wait a long time for these. These are little profiling tools, I think micro 100 calls them. So these are QPR, that number, and they're very tiny turning tools essentially, and they go in these little cool quick change holders that are really cool because they're kind of like a 0-point system for your lathe, which I think is really cool because after getting the Lang stuff for the mill, I'm all in on the 0-point hype train. Actually, it's not a hype train, it's a real train, and it's cool. It's a cool train. It's a high-speed rail train. Fusion and those micro 100 tools is not a compatible thing, really. Fusion isn't really set up to make custom turning tools, so you end up having to cheat and steal to get Fusion to actually generate code with a really wonky looking tool in the simulation, and then hope that it actually posts correctly, because the post processor you have is probably not the correct one for your machine. Like the one I'm using for this one is a modified Doosan Puma post processor, I think. And then if I have to post like radial C-axis code, I'll use some other Fanuc machine. And like essentially you hand code the entire thing. You basically get a baseline thing on the main spindle, and then you end up having to like change a bunch of start codes here and then copy and paste like new operations in between and do all this stuff. And so what ends up happening is by the end of it, you can't just, oh, I made a change to the design file, update it in manufacturing in the cam side, and then push out new code. You have to push out that new code and then be very careful about copying and pasting it into the live code that's going to be run on the machine. Bringing it all back around, I redid the program, and so because of that, the old one was really hand edited like I just mentioned. I had to then re-hand edit this one to work. And the thing with the pivots is they're not a complicated part by any stretch of the imagination, but for a C-axis lathe that has no Y-axis, and then having to align everything and get it working right with these really tiny threading tools, these really tiny boring bars, and the person running all this being like very, to a fault, crazy about the finishes and the tolerances that this 2004 lathe can produce, make the time it takes to actually make these a very long time. Once the machine is running, then it makes it pretty reliably, which is pretty cool, but it takes a long time. So here's an example in brass. This head's too short, I think, but there's this weird head shape thing, and then, you know, I need a very, very, very tiny radius down here in the corner. It's hard to do with the viewfinder. Up in the shoulder, because when it goes into Midnight's top handle, so here's the top handle. This might not actually fit in here, so I'm still working on that, but it does. Okay, cool. So that goes in there like this. You have this tolerance, this slop tolerance between these radiuses and the handle, female radiuses, if you will. Another kind of issue with older machines is tolerancing, and you can't throw a bunch of points at an older machine and expect it to run as smooth as a newer machine. Despite the Haas being a Haas, it runs a large amount of tool data, or G-code, a lot quicker and more smoothly than this machine will. So you end up doing this thing where you can make a really, really nice, precise radiused edge in this pocket here, which is cool, right? But what ends up happening is if you want to make the same precise radius edge and you design the pivot all weird with splines and stuff, you end up generating a lot of code. And if you do like smoothing infusion, which will take all those points and cut them into, or put them into arcs based on a filtering tolerance, sometimes the radius, if you will, it's more like a continuous radius, I guess, or like a changing radius, might not match the handle. So that's just one of the problems. Then you have the fact that the radius I was talking about prior is so tiny because I have a very little, the pocket thickness or the bore thickness is so thin, that the actual wall height to hold the pivot is so thin, you end up needing as much of this wall length as possible in the actual handle. So you don't want to sacrifice wall length to like add a really deep chamfer to fit a radius, because that radius in there needs to go in there, not contact the wall, and also sit flush in the pocket, if that makes any sense whatsoever. So essentially what I'm saying is there's, say, a 5 thou chamfer on the top of the bore here. That means you have to have a smaller than 5 thou radius, chamfer, whatever on here to not contact that, because we only want contact on the bore walls because that's the locating surface for this part. Yeah, so that's like one of the problems, and that's just on the main spindle. So you got all fine and dandy main spindle stuff. Well, you want to make more than one of them, and the problem with just cutting it off at the main spindle with a a cutoff tool is the quality of that surface on the back here. Let me see if I can go find one. Here's an example of one that was just parted off at the main spindle, so there's no subspindle transfer. Ignoring the tit in the middle, you can see there's actually pretty visual lines in the part. Now, I know you can get parting surfaces really dialed in, but you still end up having to be at the machine and messing with it, when you could have the subspindle do work and get a really beautiful finish on the backside. So that's kind of what I'm currently dealing with. Working on the subspindle side, you then have the whole, it transfers from the main, so you're here, right? And then you want to come in with the subspindle, grab it, you know, bar pull, because I don't have the bar loader hooked up. And while you got the spindle synced and everything clamped, you come in and you actually part it off, so you have like a lot of stability essentially holding it. Because if you bring your stock out really far, let's say you stick your stock out like way out of the main spindle here, my fingers are the spindle, and you got your part here, right, for a bar pull, and you don't support the end, well, that surface is gonna be really bad when you part it, kind of thing. So you clamp it and you support it, you cut it, and then you pull it back to the subspindle, and then you do your work on the subspindle. And what can be really frustrating, as I was talking about before with Fusion and post-processors, is the fact that there are a ton of post-processors that handle work on the main side. So like G54, let's say somewhere near your main stock or your main part on the main spindle using normal orientated turning tools, blah, blah, blah. Like that stuff's pretty set in stone. You can post all day for very simple, just main spindle facing parts. The second you get into subspindle work, what happens is, like on this one, what I do is you set the sub spindle to what's called a second home position. And on this machine, the code I have used is G55, G30, P2, and then B0. And what that allows the machine is, that's a second home reference. It's not just a floating point. You do set this under G55, or was it G59? One of those. And when you call that up, you can run the spindle there, and then you can actually use that offset to, like, that's B0, G55. And then from there, you can build your tool paths on the backside, which then has the spindle reversed depending on how the code is posted. So there's a lot of back and forth. Like, you run something, you post code, you run something, you check it, you're like, oh, the spindle is running backwards. Let me edit it and change it, or change how the post handle that. And then all fine and dandy, but like, okay, now I want to use the parts catcher. The reason the subspindle has to be at its second home is because the parts catcher actually won't activate unless it's in that second home, because of how the machine builder built the machine. I can't tool change if the subspindle is not at its 0 home position or machine home position, and we'll know that's actually at that position because this B, there's a light here for the B axis, which the B axis is the subspindle when I mention it. That'll actually light up when it's in its machine 0 home position. Then you can tool change. You can't actually tool change, as far as I'm aware, if the subspindle is even at its fixed second home position, which can lead to some interesting things, because if you have the main spindle and the subspindle synchronized, so they're both spinning, like, let's say, clockwise, looking at the main spindle, right? If you have them synchronized and you need to do work that involves 2 tools, well, you can't do that. You can tool change prior to the synchronization and bringing the subspindle up. So you would tool change, and that's how I have this code written. You tool change first, and you tool change to a tool that will not hit the subspindle as it rolls forward, because some of these tools in this VDI 40 turret will actually contact the subspindle even when X is all the way at its home position. So you tool change, you bring the B axis all the way forward, and then you use the tool, you clamp and everything, you use that tool for that operation. Well, if you want to switch tools, you need to unclamp the sub, which already you've introduced a spot that your dimensions can change. Your accuracy of your machine thing is now moving because you have, you know, this clamping function, which as repeatable as you can try to get it, at least on this machine, you're not going to be, you can't repeat within like 0.2. It's just not a physically possible thing on this machine. So you're introducing that error there. You pull the B axis all the way back, and then you tool change to the tool you want to use, and then you bring the sub spindle all the way back to the B axis, all the way back to the main. You clamp in the same location, and then you can run your operation. So if you have things that need support and you have the part pulled out and you need all this stuff going on, there's a lot of like back and forth work going on that Fusion essentially cannot handle. And in all reality, I don't know if I'm sure there's a CAM package out there that would be able to do that. I don't have the money for it, but you have to have a post processor that actually works with this control that would handle all that stuff very well. And in reality, I don't know if one exists. One probably does, but it would cost a lot of money or a lot of time to actually edit one to get that to work. So that was a really long talk on the current struggles with the lathe. And now we can actually get to making scrap. All right, so speaking of the sub spindle, this is a stick tool holder. It's I don't know, it's from Shars. It's really cheap. I highly recommend buying these things if you need some new tool holders and you plan on maybe modifying them, like this one is. It is a little bit longer from Shars, probably, you know, normal stick tool length. On the sub spindle, you're clamped like this, right? So you're upside down, and the sub spindle is spinning into the part like this. I don't know what the best orientation for you to understand is, but you got like you're spinning like this because you want the material to come into the face of your insert on the top. A lot of times, if you spin backwards, you can chip the insert this way, or you'll be like, man, the finish is terrible on this. I don't understand why. And my tool life is about 2 parts. Sometimes it's your rotational thing. The cutting, when you cut on this lathe, it has no y-axis, and it's a slant bed. So the x-axis is actually I don't know what you call it, the table it's sitting on slides at a 45. So everything, all the work is done at this 45-degree angle. There's very specific reasons why the machine is built that way, and anyways, that's how it is. You slide this tool down, right, and you got your sub spindle doing its thing, spinning, and you come down and you're trying to hit center line of the part. And when you hit center line, you know, you have a good chip formation, whatever, and you get a nice surface finish. Yesterday when I was doing this, and this is really the last stage of the entire process to make these pivots, is the center line, you could watch it, it would leave like, it would peel material into like a weird mushroom shape and then basically knock it off because there's nothing supporting it left. And that basically told me that the tool was not on center line. And the issue with this lathe is I readjusted the turret as close as possible. The issue with the lathe is if you've adjusted the turret as close as you could get it to center line, so you know you spin the turret and X0, hopefully the tool tip is center line of the spindles. Doing it, you have very little room for error, so you end up having to shim the tools after via modifications. So often what I'll do is I have some heat treat foil. This is just some stainless, but it's 2.5 thou in thickness. This works really good, and I've shimmed a lot of tools on here. Sometimes the tools don't need it. It's just a matter of the machine's old, the tool block holder could have burrs and stuff in it. You do your best to deburr the whole thing, but at the end of the day, like, you're fighting with a lot of different things that could cause this tooltip not to be on center line, and you're talking within 2 thou, you'll either have a tit or like a mound or a hill or something. So after adjusting what I could and deburring what I could and making sure that everything was as close as I could, basically the last thing I could do is make this tool holder shorter, so I ended up surface grinding off like 1/2 thou, maybe 2 thou I think. So we're actually going to install this, and now we're going to see if it's cutting on centerline. But yeah, these toolbox, I thought they were hardened steel. They are not whatsoever. You can see this mark here is actually from the screw, the set screw holder digging into it, which is actually kind of wild. This is the bottom face because it sits like, you know, orientated like this. We got these 2 set screws, and then you got a single one because I'm missing the other one. But it's crazy that it dug in that much. And yeah, so let's try and set that up and see if we can get a better rear surface finish. All right, here we are in the lathe. This is the holder here. You can see it's a double-sided holder, so you got a main side. This is just a grooving tool. I put it next to our backside tool because you don't need any room to use this in this clearance-wise. There's a lot of stuff lathes involved that everything clearance is really important versus mills. You just pick the tool holder that fits for a mill. On a lathe, the tool holder might work, but then you turn the turret around and suddenly that tool you're not actually using, the other one, wants to contact the workpiece. And yeah, lathes are a good time. So we got our stick holder here, and it goes in here on this pocket. You could usually use these screws to manually adjust the height, but because it's already maxed out and it's flush against this top surface, which is really its mounting surface, everything is upside down because of rotation on the spindles. Because I ran out of that adjustment, I surface ground some of it off to gain some of that adjustment back. Because now what we can do is that we can actually turn this top screw right here, and it's a little hard to see under the hose, and push the tool holder down. So we'll basically mess with that until we get a nice clean backside surface. Another reason this tool holder is so short is because the actual pocket depth is really short for this. The nice thing about these Shars holders is because they're cheap and they're not hardened, you can just bandsaw them, so that's what I ended up doing on this one. When you install stuff, make sure you're not installing it up against a back pocket that isn't used as a locating surface, because what can happen is if that back part of your tool is not precisely ground and you put it up against the back surface that was never intended to be a locating feature for your tool holder, and you tighten the screws, you can force the back side of your tool into that wall and actually kick the tool holder not where you expect it to, kind of thing. So I left like just a 1/16 of an inch away from that back wall, and just to avoid that problem. More and more I figure out why people say being a machinist hurts your back, because you're always leaning over. You can see that the tool is now below centerline. It's a little hard to tell because it's upside down. I think that would be, I don't know. One of those directions. But that's the direction we wanted, so. Alright, I'm gonna keep adjusting the set screws until we're at the centerline, and it leaves a nice finish. What's interesting now that I've gotten it a lot closer to centerline, the line it leaves cut into the part when you back off of it is much more defined. But maybe that's because we didn't move in Z at all. But it's really close. It's just a little tiny tip. Not a sharp one. So I think that means it's too low. I don't know. I think we went too high on that one. Yep, this is really hard to do because the adjustment's so close. Cool, I'm feeling good about that one. Really close, still left a little center. And again, I don't know which direction to go on that. Alright, so that's too low. This is taking a while. Alright, we absolutely nailed it. It's leaving a beautiful finish. I find it really interesting that when you back the cutter away in the same Z position, it leaves a ring, but right when it gets to this position, the ring stops being cut, like rolled over. So I thought that was kind of interesting. There must be something stuck on the cutter or something weird in that. But that's definitely a really nice finish, which is what I'm going for. I'm a little worried about the position changing because it's only on 2 points, but I'm gonna just gently put a set screw somewhere, maybe just tighten this loose one in the back and just snug it slightly. And what I'm gonna do is redo the offsets like we were doing before, and then we'll go through an entire pivot program, and I'll probably call this a very complete video. So I got our backside tool, all the offsets and everything. So we're gonna run one program all the way through and see what it goes. number 38 drill for a 664 internal thread is what I determined was the best. This thing was not easy to get on centerline, but it's now working really good. I'm curious to see how it goes in 17.4 Beach 900. Parting the backside before it gets milled, so there's a relief behind it, so the end mill, when it's doing axial live milling, there's a lot less tool load. Nice little chamfer on the end. 120-degree spot drill, I think. And we come in with a really tiny micro 100 threading tool. So it's very tiny to do these 664 threads. So I'm actually going to turn the coolant on for this one, otherwise the core will get packed with chips. And that's the last stop on this side, so once that's done, we'll start moving over and involving the V-axis. So here's one of the pivots to the 664 thread. So it is tiny. Could be a little tighter. Bar pulled out material, and remove some of the material behind that back shoulder so we have room to deeper the back edge of it. Which is actually pretty cool and was created using Fusion's deeper toolpath, but setting it to 4th axis. Surprisingly, it worked really well. front of our B-axis and the sub-spindle. And we're going to switch to our tool that we spent so long getting centered, and hopefully it gives us a nice finish. So here's our done pivot. That back finish looks really nice. It looks like the deburr, I think the pivot head is too thick, so we'll have to mess with the compensation for the our back facing tool. This is supposed to be 22 thou thick. And it's pretty close. We're a couple thou off, so basically 3 thou off. So need some adjustment there, but as far as doing 2 transfers, 2 bar pulls, and reclamping and everything, that's not too bad. And the finish is a lot better than it was yesterday on the back face. And the reason it's got to be so good basically is because if you tumble it and it's not good, lines will show up and the little pit will show up really obvious in the tumble finish, and it just doesn't look as good as it could, especially being on the front of a nice knife. So yeah, thought you might like to see it as it sits in the handle. That outside contour is too wide, so it doesn't actually sit all the way in the pocket. See if it fits this one. Yep, too wide. Does look cool though. Can't really use brass as a real pivot material though. Alright, that's about all I got for this video. This is probably a long video, but yeah, hopefully do a little more consistent, well not consistent, but more video uploads. Thanks for watching.